Till now, we know about PSK, which stands for phase shift keying. But in the terms of wireless communication, another technique was also developed for continuous phase shift keying. Also, it is encoded with bits altering between quadrature components. This is known as minimum shift keying or MSK. In today's lecture, we are going to discuss about GMSK modulation technique that is known as Gaussian minimum shift keying, which is a modified version of MSK. It is a simple binary modulation scheme that can be compared as a derivative of MSK. If we see the carrier spectrum, it can be noticed that the side lobes are further reduced by passing the modulating NRZ data waveform through a Gaussian pulse shaping filter. The filter converts the full response message signal into a particular response scheme where each transmitted symbol spans several bit periods. The GMSK pre-modulation filter has an impulse response and is expressed as HGT is equal to root over pi by alpha exponent of minus pi square by alpha square multiplied by t square. And the transfer function is HGF is equal to exponent of minus alpha square f square. The parameter alpha is related to B. The 3 dB baseband bandwidth of HGF by alpha is equal to root over ln of 2 by root 2 B is equal to 0.5887 by B. The GMSK filter may be completely defined from B and the baseband signal duration T. It is therefore customary to define GMSK by its BT product. GMSK bit error rate. The bit error rate for GMSK was first found in MER 81 for AWGN channels and was shown to offer performance within 1 dB of optimum MSK when BT is equal to 0.25. The bit error probability for GMSK is expressed as PE is equal to Q multiplied by whole root over 2 gamma EB by N0, where gamma is equal to 0.68 for GMSK with BT is equal to 0.25 and gamma is equal to 0.85 for simple MSK where BT is equal to infinity. Generation and TR in GMSK modulation. Generally, there are two main ways in which GMSK modulation can be produced. The simplest way is to filter the modulating signal by using a Gaussian filter and then connect it to a frequency modulator where the modulation index is set to 0.5. In practice, this analog process is not suitable because component tolerances drift and cannot be set exactly. Another method is by using a quadrature modulator. The term quadrature signifies that the phase of a signal is in quadrature or 90 degree to another one. The quadrature modulator uses one signal that is said to be in phase and another that is in quadrature. To this type of modulator is frequently said to be an IQ modulator. Utilizing this type of modulator, the modulation index can be maintained at exactly 0.5 without the need for any settings or adjustments. For demodulation, the technique can be used in reverse. Advantages of GMSK modulation. There are several advantages of GMSK modulation in the domain of radio communication system. As it is improvises, the spectral efficiency compared to another phase shift keying methods. Also, it can be amplified by a nonlinear amplifier and remain undistorted. GMSK Gaussian minimum shift keying declared to be particularly successful form of modulation for GSM and some other radio communication systems. Its combination of spectral efficiency and capability to enable efficient power amplifier operation enabled it to be an excellent choice for radio communication system of the time. With this, we have come an end to this session, and today we have learned Introduction to Minimum Shift Keying, MSK, Gaussian Minimum Shift Keying and its characteristics along with impulse and transfer function parameters, GMSK expression for finding error bit rate, generation and TR in GMSK modulation, advantages of GMSK modulation. We'll meet again with another topic in wireless communication. Till then, bye.